All right. Hello, everyone, and welcome. This is Gokhan. I'm a managing director at IOSG Ventures. We're one of the investors of Ingonyama. Today's panel is about the client-side proving. So if you guys look at most of the roll-up structures at this point, they're using server-side proof generation and witness generation. That is for the purposes of scalability, but then if you start using client-side proving, that brings additional benefits such as privacy. So this is what we're going to discuss today. We have a great line of speakers here. Maybe we take a turn of introductions first. Would you like to start?
Sure. Thank you. So hello, everyone. I'm Xiaohong Chen. I'm the CTO at PySquared. So it's very nice to be here today, joining the panel, and also great to see many of you joining the discussion. So I think it really shows how much interest people have on ZK verifiable computing. So that's great. So PySquared, we established at the beginning of the year. So our mission and vision is to offer universal verifiable computing for all programming languages, virtual machines, and so on. And I think what's unique at PySquared is that we're taking a semantics-first approach, right? So for those of you who don't know, so I can think of the semantics of a language as being the ultimate rigorous mathematical definition of a language. So in theory, from it, you can derive all the language tools you need, including ZK tools, right? And we're taking that approach, and we're really trying to bring the ability to generate ZK proofs for the execution of any programs in any programming languages to the developers. Yeah, that's our mission, and I'm very much looking forward to the discussion today. And I think there's going to be a very promising opportunity in the future where we can integrate, right, the universality that's provided by PySquared using the formal semantics and the great improvement on the ZK side. So looking forward to this discussion.
Hey everyone, my name is Steven. I work at Risc as the head of strategy. At Risc, we've built the first and arguably fastest ZK virtual machine. Along the way, we've had a lot of exciting integrations, everything from ZK rollups to co-processors to provable applications. We've also built out Bonsai, which is our cloud prover, as well as now we're building Boundless, which is our decentralized protocol that will hopefully power all ZK applications.
Hi, I'm Diego. I am the co-founder of Aligned, and before that, head of research at LambdaClass. At Lambda, we have been working on different projects related to ZK, Web3. If there is a difficult problem, we like to tackle and learn, and we've been lucky to be able to work with many of the people and learn from them. And we hope we can help really accelerate the roadmap of Ethereum and the adoption of Web3, because it can have very transformative things for, at least I live in Argentina, and crypto provides an interesting use case to deal with many of the problems we face day to day. So a pleasure to be here sharing this panel with you all.
Hey everyone, my name's Joe. I'm one of the co-founders of Aztec. We're building kind of a privacy layer for Ethereum, and we've been focused on, I guess, this topic of client-side ZK for nearly 6-7 years now. We started back in 2017, and yeah, it's evolved a lot since then. I think when it first started, you were doing proofs inside every Ethereum transaction because gas was 10 Gwei. So it's come a lot. So it's come a long way. So I'm excited to discuss it all with you today and have a great panel to discuss it with as well. So yeah, thanks for having us.
All right, yeah, thanks a lot for the introductions. And yeah, maybe let's start with I think, like, Joe, you guys have been working on this for a long time, and recently it's becoming more and more popular. More teams are getting into space of client-side proving. If you could give us, like, why do you think it is becoming more popular, or maybe the evolution of the client-side proving as well from your side, and then we can ask other panelists to add if they have any comments.
Yeah, I think it's probably two reasons it's growing in popularity. One is just a realization that this is kind of the only way to get kind of cryptographically neutral privacy. Like all other forms of privacy, you usually have to trust some third party to be involved, and we're all building kind of decentralized technologies here that are meant to minimize trust. And so I think client-side ZK is probably the only way to get credible privacy with the same trust assumptions. And I think the reason it's kind of like shot to fame over the last year is probably, or maybe last like 3 years, is just the evolution of ZK proof systems. Yeah, when we first started, we weren't even really doing kind of ZK snarks or ZK starks, anything like that. They were Sigma protocols. So the only kind of proof you could actually prove on a device was a very primitive form of zero-knowledge proof, like a Sigma protocol. And over the last kind of, yeah, well, probably 5-6 years, with the invention of Plonk, other kind of, other types of proving systems, the amount you can prove on a kind of resource-constrained device it's probably come down, it's increased several orders of magnitude, and the proving time has come down significantly. So now we can actually prove smart contracts, passports, really interesting things on phones, and yeah, I think it's only going to keep getting better with like WASM and web GPU provers as well.
Yeah, I think that I coincide. I think that the fact that proof systems have gotten like way better, and that also writing ZK now is way easier because we have ZK VMs, or we have Noir and other stuff that makes coding like simpler. We start asking more things about ZK. We say, okay, if we could prove this, now we want to add all these other things, because we are also like concerned about all the information that we leak to the web and that can be used for bad purposes. And with all the rising concerns of AI and all that, we want to be like extra sure of the things we leak to the web and everything. So it's going to become more and more important. And also with the development, for example, of ZPUs, that is to say specialized processors for doing ZK, is going to also make this more commonplace as costs go down and everything.
All right. Would you like to add something?
Right. So I totally agree with what has been said. So I think the privacy is definitely one of the main motivation. I think I want to mention the other one, which is, I think, the elephant in the room, which is also performance. And I think I like to bring a new angle here, which is, again, the formal semantics. So at Pi Squared, as I said, the approach we're taking is, we call it proof of proof. Right? Actually, that's what Pi Squared means. And it's a zero-knowledge proof of mathematical proof. So we're doing it in 2 steps. And so basically, we first generate a mathematical proof using the formal semantics, and then generate ZK proof of the mathematical proof. And we are actually using also ZK VMs to do the latter. So it's compatible with any ZK VM. Actually, we are, like Risc and LambdaClass, their tools have been part of our current infrastructure. So I think this approach brings some unique benefits in the sense there are just so much optimizations that are possible on the mathematical side, before you get into ZK, because we understand that the ZK is like a very expensive world, right? So you like to optimize your problem as much as possible before you get into that territory. So I think there's some, as I said, I'm really optimistic that there's going to be some very promising integration going on here in the future.
Pretty interesting. We're going to talk about some of the interesting use cases the proving side brings, but maybe before that, it's been like a lot of teams have been working on this for a while. What are some of the remaining bottlenecks on the technology side, like that we still have to do some leaps? If you guys could talk about that, that would be great. Xiaohong, would you like to start this time?
Yeah, I can start. So I think I would maybe speak from the performance side, and then my panelists can add other aspects. I think performance side, like proving generating ZK proof of one session is definitely one issue, but also proof aggregation. If you have like multiple ZK proofs, want to like generate a batch proof in the end, and the generation time, even the verification time cost because you want that to happen on chain, that can be also very costly. So I think that's one. In my view, it's one of the bottleneck issue right now. Yeah.
Yeah, I can talk a little bit more to performance as well. I think over the past year or two, at least for the RAM requirements for our prover, it's fallen from 16 gigabytes, and we've proven it all the way down to 4 gigabytes. We also have quite a few teams playing around with mobile provers. So we've had our prover run on both iPhones and Androids. And iPhones, you have metal acceleration, so it's actually really easy. And sorry, not that easy, but it's doable because we already have Metal support on MacBooks. So I think we're getting there. The performance, you're talking about like an easy 10 to 100x slower than your average MacBook on an iPhone, and you're talking about 100 to 1,000x slower than GPUs. But it's also important to think about, like, for a lot of privacy use cases, you actually don't need that much compute. You're proving facts. You're not proving like I can do all this computation. So at least for some of the privacy use cases that we've seen so far, I actually think we're getting there. We're probably still a magnitude or two off for ZK VM-based client-side proving, but I don't see it as, probably in the next year or two we'll get there.
Yeah, I think that the problem that you face is that in order to prove a program, you have to keep the witness. And in general, if you want to prove a long program, you have to keep this long witness. Of course, then we had this idea of doing like continuations or sharding, where we split the program into smaller parts, and then we prove each part, and then we aggregate them recursively to shrink proof size, because then we would get like several proofs, and verifying that on chain would be expensive. Besides, we would have to pass all that information. So the big thing has been on how we can shrink this witness and how we can perform recursion more efficiently. And that has led, for example, to looking either for better hash functions or maybe elliptic curve constructions that have certain properties. But right now, I am excited about some developments where you can have, for example, folding using Starks. And so that would mean that you can still do these sharding or continuations, but instead of proving them, you just fold them, which should be ideally much faster than that. And so you don't have to do the recursive proving, you just do the folding, and then you just prove this last part and you generate the proof. So I think that we will see some great improvements in the coming months related to that. I don't know if then we can ask Risc whether they have plans or anything to add some of this new stuff.
Yeah, on the folding side, I mean, that's how our proving system works. We've got kind of recursive aggregation of our folding down to about 1 second. So every kind of smart contract call on Aztec is a fold. And so we use exactly that continuation logic to keep going. I think the challenge with trying to get there, and we're not there in all cases yet, is just the limitations of the devices that you're proving this on. And Stephen said kind of 4 gigabytes earlier. Like, the reason this is like an important number is because that's how much memory the WASM VM has, and that's kind of usually where this is being proved on a client-side device. When you go to mobile, depending on the device, you normally get the tab killed or the application killed at 1 to 2 gigabytes. So there's a little bit of kind of work to do to get it well under a gigabyte of memory, I think, to get these provers working in all situations. And at the moment, they're mostly CPU provers. Kind of access to GPU in like a browser context on people's devices it's a standards kind of battle at the moment. That there is web GPU, but it's not supported everywhere. And there's also some strange SIMD WASM opcodes that let you do fast vector kind of multiplications, but you have to write very specific algorithms for these kind of targeted execution contexts, and it's very complicated. So maybe it's a problem for LambdaClass to solve.
Perfect. One form of client-side proving we see in the market is ZK TLS. I think over the last year, there has been 5-6 different projects have raised in order to develop this technology. I would love to, maybe Diego, if you could explain us what ZK TLS is at a high level, and then I would love to get others comment on it. Like, okay. What do you think about it?
Yeah, so basically we know TLS protocol that is used to exchange information securely in the web. But suppose that is something that we use in Web 2 and where we are used to it. But when we are using Web 3 applications, we have the problem of showing the authenticity of that information. So how can I show you exactly that information is in a given website and I obtained it from there? And in some cases, I would like to use some information that is available on some server or something, but I don't want to reveal that information because it may be something sensitive. So, for example, I wanted to show something related to my bank account, but I don't want to show how much money I have there. So using a ZK proof, I could show the integrity of that information and at the same time prove something about it without disclosing it. So this opens the door to many different applications because we are connecting somehow Web 2 and Web 3. The only problem is that doing this with current ZK provers is not quite efficient, and so some projects have been exploring the idea of using TEs, but I think we will be close at some point of using full ZK and not necessarily trusting the hardware, because we already know that sometimes you can get exploits on hardware and everything. So yeah, that's the basic idea.
Yeah, I think with TLS Notary, like, it's in this class of kind of, I guess, use cases where you can prove something about Web 2 on Web 3. ZK email's the same. For me, TLS Notary it's an interesting one because it would let all of the internet kind of go on chain or go into ZK proofs, but it doesn't quite meet like the trust assumptions we want from, like, let's say, client-side ZK. There is a trusted notary usually. I think that may change over time. So I think that the use cases are still very exciting, but for me, there's a web standard that's been proposed. I think it's about 10 years old now, but it hasn't quite made it into the standards track, where they actually added a signature to the HTTP body. And so then you could have like a fully trustless kind of ZK notary for web proofs, but you don't need to have the TLS kind of notary in the middle, because the server would just sign a message and you could rely on the same just like ECDSA signatures or something to do that. But I think it's an amazing use case if we can get there.
Yeah, I think the only other thing I'd add is, like, at least from our perspective, it actually may not make much sense to implement something like ZK-TLS in the ZK VM. Really what instead we think about is how do we combine and aggregate these proofs in the ZK VM level, right? This might be just verifying a generic proof or verifying a Groth16, whatever the ZK-TLS ends up being, and then doing the computation in the ZK VM. We think this architecture is going to be pretty common, and the most exciting thing is, like, proof verification in VM, in ZK VM is getting to a point where I'd argue it's quite competitive with the pure aggregation circuits. The ZK VM, with accelerators, is actually performant enough that we should be able to bring in lots of different proof systems, each specializing with their own own specific thing.
Maybe we can start with the use cases. What are some of the overall client-side proving use cases that you're excited about? ZK-TLS is one of them, and it enables, like, under-collateralized lending and borrowing potentially in the market. Xiaohong, maybe you can start.
Well, I think I will let the other panelists start, and I can comment later.
Sure, I can go. I think ZK email's kind of the one that I'm most excited about right now. Kind of it's similar to TLS Notary, but the main kind of idea is you can take any email in your inbox and you can prove kind of statements about that, like who it came from, contents of the emails, dates, all those sorts of things. And if you kind of think about the data that's inside your email inbox, then it enables a huge amount of use cases. You can do things like, ZK-based credit scores, where you can prove stuff about your bank statements. Under-collateralized lending is a really exciting one. You can also do stuff for gaming. People have been trying to put games kind of on chain for a while, but most people who play, like, fantasy sports, you get a lot of emails when you play fantasy sports, and so you could do, like, side bets on actual fantasy sports, and you don't have to recreate, like, a game. You can just use your existing kind of DraftKings or fantasy app, but have, like, side bets on chain around the result of a fantasy league, which I think is really cool. Yeah, in terms of, like, maybe just zooming out a little bit though on the client side thing, we've talked about privacy a lot, but the other thing that's exciting about client side is kind of mass parallelization. in a kind of blockchain context, we've all kind of got used to 12 to 30 million gas as like the limit of what you can do in a transaction. With a client-side proof, if you change the device, you can actually prove a lot more, and you get kind of mass parallelization because each user's proving a lot more instead of having to go through like one centralized bottleneck. So there's other types of use cases that can take advantage of that, like trading or just things that require a lot more compute. That I think is another area we can go.
Yeah, in my case, I like all those applications, especially I think on-chain gaming would be nice to have some kind of leaderboard where you can compete and all that. Of course, I think that if we wanted to do that on top of Ethereum, we would face the problem of verification costs. And that's why we've been developing Aligned to be able to handle large amounts of proofs and reduce costs significantly. But yeah, that is something that I'd love to see. And then I can think also of payments, like having a more like cash-like system. That would be also interesting, at least from a philosophical point of view. But I don't know, it's coming from Argentina, it's nice to have like all these kinds of DeFi applications and being able to do things with privacy. It's going to be nice.
Something else our team has been thinking about is we actually talk a lot to the Ethereum Foundation. And one of their goals, at least one of Vitalik's goals, is to enshrine ZK and also to prove every single Ethereum block. And you know that EF is a big stickler on hardware requirements. Like they really push solo staking. And similarly for proving, one of their requirements is we need proving to be super accessible. And I think right now, if you want to prove Ethereum real time, not real time, but like keep up with the block production, you need something like a few thousand 4090s. It's like crazy amounts of stuff, millions of dollars of compute. And just with client-side ZK and all other things, it's actually getting us to a point, hopefully in the coming few years, where if, for example, all the stakers or all the provers go down, that it's possible to continue generating proofs for Ethereum using very minimal consumer hardware. And that's basically one of the requirements the EF's going to have to enshrine ZK. Similarly, maybe in the future when you're doing a transaction, you actually prove the transaction locally and you're submitting that transaction to Ethereum. And that's like the enshrined ZK execution that Vitalik wants, right? So a few ways, a lot of interesting ways that I think will fundamentally change how Ethereum interacts and does its execution. And all of that will be dependent on making sure that anyone can generate these sort of proofs.
Yeah, so I like to maybe zoom up a bit and talk about data privacy, privacy in general. And I like to maybe bring a new lens, through the concept of formal semantics. So, once you have a formal semantics, then any computation of any program in any language becomes a mathematical claim you can prove, right? And right, so I think another benefit is about compositionality and parallelization, as Diego and Joe mentioned, but also the fact that once you have a statement written in mathematical form, you can actually use mathematical operations to hide some information. So I think a typical use case, probably not very related to client-side ZK, but in the AI, in the integration of AI and ZK, is where, for example, you can right, you have a large language model, right, of interest, and you want to get suggestion from it, but for some reason, right, the model is private, right? So, but you want to make sure that the suggestion you got are actually coming from the model, which should have some property, right? So in that sense, the model itself, the data is private, but the property the model should satisfy is public, right? So in that sense, you could easily write a mathematical statement which something like there exists a large language model M, which satisfies this property, and it gives me this suggestion. So I can write a mathematical statement like this, I can generate a mathematical proof, and then ZK it. So I think what's interesting here is if you get into the territory of mathematics and formal semantics, the expressiveness can go up a bit. So I think that's why I think there's some very promising future, where we can integrate the two and take the best thing from both worlds.
Thank you. And maybe as a closing note, like you guys have mentioned that there has been a lot of improvements on the software side, and hardware acceleration also helps, at least on the proof generation side. I'm curious, like, what would be your guesses about like next 5 years? When would be able to get the mass adoption, let's say on the client proving side, when the tech would be ready for that? How does the next 5 years look like for the adoption of this technology?
Yeah, I think we're kind of hitching our wagon to kind of the per application circuits approach right now with Noir and kind of compiling circuits. That's kind of just a factor on like when we want to launch Aztec next year. And so I think within the next 1 to 2 years, I don't think there'll be kind of like fully usable ZK VMs client side. But after that point, I think maybe the VM approach will kind of take hold. And so, yeah, I think adoption can happen now, in my opinion, but the underlying technology stack may change over the next 5 years, and it will probably shift towards a VM approach. But yeah, we need to kind of see what the latest Apple chips can do, and kind of push things that way.
Yeah, I think that ZK already is in a point where we can start massively adopting it. We still have to reduce a little bit verification costs. I think, of course, on the proving side, we still can make things way better, but I think that if these new folding schemes for Starks work, then that would be like a massive boost, at least for proving. We also have like prover networks that can help reduce costs and offload expensive computations. I think that we still have to onboard lots of new people. That's why, for example, in Aligned, we've been looking to develop like some applications where people can play games on chain, submit them, and verify their proofs. And I think that we will see like some changes in how rollups behave. Maybe in 5 years, the rollups we have will be very different from those we have right now. But it's hard to say. We've seen that if you ask somebody what would be the state of ZK 4 years ago, he would not have been able to imagine that this was going to be possible. And if you think of all the developments we've seen over these years, it's been amazing. So I don't know. I am excited about the next 3 or 4 years. We will see some crazy things happening.
I think in 5 years for us, and I think part of this is also the vision for our entire team. About every other month so far, we have a bank or a government or a healthcare organization or something along like those Web 2 lines reach out to us, asking for some sort of privacy-preserving security guarantees, some sort of verifiability in their, like the U.S. Energy Laboratory did some sort of research into proving the energy grid. And every other month, teams will come to us, and they'll build out these really cool POCs, and it'll be really cool projects that they can take back to their teams. But nothing, truthfully, has really come about of it, because obviously these orgs move super, super slow. ZK, truthfully, is totally untested outside of crypto. But like I'd say we really do believe in these use cases. We're waiting for, hopefully in the next year or two, a Halo use case for one really large team that proves the validity of and usefulness of ZK in these different markets. And we also think there's a lot of regulatory pressure to use this technology. Regulatory pressure coming from the EU, coming from America, and we're slowly starting to see more and more people talk about this tech. I think it's only time. Truthfully, our performance, maybe it's only a magnitude off of what's required for a lot of these use cases. It's more so breaking into these industries and making sure that people can trust ZK, which is an unproven technology so far.
So I'm also very optimistic about the future because of all the reasons the other panelists have mentioned, but also because of the amount of optimizations that are possible in a semantics-first approach, and which are like entirely orthogonal to the ZK performance. So we can really add them up together. So imagine you have a while loop, you have some recursive function, and if you formally verify it, you can use the invariant to skip the execution of the entire program and jump directly to the end. right? So it's like using formal verification as the ultimate optimization of program execution, right? And that's possible in the formal semantics world at Pi-squared approach. And as I said, that adds up to right, all these amazing ZK improvements, performance improvements. So we can put them together and offering, I think, the community, I would say, the next generation of virtual computing, which is for all languages and at amazing performance.
Yeah, 5 years is too long for crypto. I should have asked for 1 or 2 years, actually. Well, yeah, thanks a lot for all the insights, the panels, and thanks a lot for listening. That's all for today.